Okay, here are your notes for section 10.4 with circles. Take the time to write this down, pause it. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. An inscribed angle, meaning that the vertex is on the circle, has to be touching the circle and only the vertex. It's exactly 1/2 the measure of its intercepted arc. So the measure of angle ABC is exactly 1/2 the measure of arc AC. Notice the documentation and how it's written. Measure of angle ABC, 1/2 the measure of arc AC. Take the time to write that down and draw it. Next page. Find the indicated measure. If you have this drawing, pause it, draw it, label it. Make sure you put your degrees in there. Okay, we're back. The measure of angle T. Measure of angle T is an inscribed angle. It's going to be 1/2 of whatever its arc is. Since its arc is 48, the measure of the angle is 24. Make sure you label it properly with degrees. The measure of arc QR. Arc QR. Little extra work going to be included in this one. You need the measure of arc QR. It does not have an inscribed angle to work with, so we're going to have to work with the one that we do have. 50 degrees is in this vertex right here, which means that arc over here, its intercepted arc, is 100 degrees because an inscribed angle is 1/2 of its arc. So we know that that's 100 degrees. This point right here in the middle of the circle tells you that TR, segment TR, is a diameter. It cuts the circle perfectly in 1/2. The point shows you that it goes right through the middle. Well, if that cuts the circle exactly in 1/2, we know the full semicircle has to be 180 degrees. Therefore, if the red arc is 100 degrees, the measure of arc QR has to be 100 degrees subtracted from 180 degrees. Measure of arc QR is 80 degrees. Next page. Find the measure of angle TSR. Pause it. Draw this. It'd be fun. Maybe get the compasses out. You could draw the little circles. The measure of angle TSR. That's supposed to say TSU. That would help. The measure of angle TSU. Do that. Measure of angle TSU. The only information we have is that the measure of angle TRU is 31 degrees. If that's 31 degrees, its intercepted arc is 62 degrees. The angle is 1/2 of the arc. And perhaps you've already noticed this. Angle TSU is also inscribed. Its vertex is on the circle. And it inscribes and intercepts the exact same arc that angle TRU did. Therefore, the measure of angle TSU also has to be 31 degrees. Next question. What is true about the measure of angle STR and the measure of angle SUR? The measure of angle STR, which would be here. What's true about the measure of angle STR and the measure of angle SUR? If you checked into that yourself, answered it, you find out that they are equal. Don't say congruent because we're talking about their measures. This measure is equal to that measure because they intercept the same arc. SR. Which leads us to this. Pause it and write it down. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. In the previous example, we said the measures are equal. but saying the angles are congruent is the same. Write that down. A polygon is an inscribed polygon. There's another vocabulary word. If all of its vertices lie on a circle. Vertice on a circle, vertice on a circle, vertice on a circle, vertice on a circle, vertice on a circle. They all have to lie on the circle. The circle that contains the vertices is called a circumscribed circle. Goes all the way around the polygon, like circumscribing the globe. Inscribed, circumscribed. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary, adding up to 180 degrees. It's the only way that it works to make a quadrilateral be inscribed in a circle. They have to be supplementary. Find the measure of angle A only if its opposite angle adds up to 180 degrees. Measure of angle A is 69 degrees. Find the measure of angle B, its opposite angle, subtracted from 180 degrees. (82 degrees). Measure of angle B is 82 degrees. Measure of angle A is 69 degrees. If you add all four of them up, they would be 360. But opposite angles must be supplementary. And the last slide. You're pausing it when needed to draw these pictures and get everything written down. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. So here's your right triangle. It is inscribed in the circle because you've got three vertices. The hypotenuse has got to be the diameter. They did not give you the center point in here and tell you that it's the diameter, but because that's a right angle, it has to be. Because 90 degrees means that its intercepted arc is 180. And we know that 180 degrees is half of a circle. Converse of that. If one side of an inscribed triangle is the diameter of the circle, if one side of an inscribed triangle, all three vertices have to be touching the circle, is a diameter of the circle, we know that it's a diameter because it shows that it goes through the center. It has to be the largest chord available. Then the triangle is a right triangle. So if we know that that went through, now we know that it's a 90-degree angle, and you have a right triangle. Conditional statement, if a right triangle is inscribed, then the hypotenuse is a diameter. Converse, if one side is a diameter, then the triangle is a right triangle. All the way back to chapter 2 when we did converses and inverses and contrapositives. All right, so go back through, double check the notes, make sure you have everything, and now you can start your assignment. That's the end of 10.4 notes.